Hello, this presentation is on trigonometric functions and right triangles. What is trigonometry? Trigonometry is the study of relationships among the sides of right triangle. For instance, if we have a right triangle with sides A, B, C, then trigonometry will be the study of the ratio of the sides, which could be A over B, or A over C, or C over B, etc. In trigonometry, there are 6 trig functions. So what are they? Let's take a look at this right triangle with an acute angle theta. There's another acute angle also. This is an acute angle, this is an acute angle, but we're going to focus on the acute angle theta. Acute angle means it's angle whose measure is in between 0 and 90 degrees. So if this is true, then the following functions are true. What are these functions? Well, let's start with the sine function. Sine function, or sine of theta, will be equal to the opposite divided by hypotenuse. So it would be OPP by HYP. Opposite of a hypotenuse. And then we have the cosine of angle theta. Cosine of angle theta, it would be the adjacent of a hypotenuse. So adjacent over hypotenuse. And then tangent of angle theta. Tangent of angle theta, it would be the opposite over the adjacent. So the opposite over adjacent. Now, sine, cosine, and tangent have reciprocals. The reciprocal of sine, it will be cosecant. So the reciprocal, which means we just take the reciprocal of the sine function. Since the sine is opposite of a hypotenuse, then the reciprocal of that will be the hypotenuse divided by opposite. And cosine is reciprocal of secant. So secant will simply be hypotenuse over adjacent. And the last one, which is cotangent, and a cotangent is reciprocal of tangent. So if tangent is the opposite of adjacent, then cotangent would be adjacent over opposite. So these are the 6 trig functions that we need to know in trigonometry. Let's move on to example 1, first example. Example 1 says find the 6 trig functions of angle theta. This is our angle theta. This side would be the opposite, and this side will be the adjacent, and this side will be the hypotenuse. And as you know, the hypotenuse is always opposite to the 90 degrees angle. So let's start with the angle sine. So sine theta, which will be the opposite of a hypotenuse, which is 4 over 5. 4 over 5. And then if we do cosine theta would be adjacent of a hypotenuse, which is 3 over 5. And then tangent theta, which is opposite of adjacent, which would be 4 over 3. Now, to find the all the three trig functions, which are the cosecant, secant, and cotangent, we simply take the reciprocal of sine, cosine, and tangent. So cosecant, which is the reciprocal of sine, will be 5 over 4. And secant, which is the reciprocal of cosine, which will be 5 over 3. And a tangent, which is the reciprocal of, cotangent, which is reciprocal of tangent, which is 3 over 4. Example 2. Question says find the 6 trig functions for angle G. Here's angle G. So opposite to G will be 24. Adjacent to G will be 32. And then the hypotenuse, which would be the 40. So let's start with sine. So sine of angle G is opposite, which is 24, over hypotenuse, which is 40. We can simplify this. 24 is divisible by 8, and 40 is also divisible by 8, so 5 over 3 is the answer. Then next one we do cosine of angle G. Cosine of angle G, which would be the adjacent over hypotenuse, which would be 32 over 40. And 32 is divisible by 8, which is 4, and 4 is divisible by 8, which is 5. And then the third one is tangent of angle G, which is opposite over adjacent, which is 24 over 32. 24 by 8 is 3, and 32 by 8 is 4. Now for the remaining 3 trig functions, we just take the reciprocal. So in regards to cosecant, which is the reciprocal of sine, which is 5 over 3. And secant, which is the reciprocal of cosine, which is 5 over 4. And a cotangent, which is the reciprocal of tangent, which is 4 over 3. Example 3, if tangent of some angle A is the ratio of the sides of 5 over 3, find the values of the remaining 5 trig functions. It means we need to find the value of sine function, cosine function, cotangent, secant, and cosecant. So if we draw a triangle, and let's assume this is angle A, that's a 90 degrees. So this must be the hypotenuse. This is the opposite, and this is adjacent. So according to this equation, since tangent of A is 5 over 3, so 5 must be the opposite and 3 must be the adjacent. So the hypotenuse, we can find it by using Pythagorean theorem. So we do c squared equals 3 squared plus 5 squared. And c equals square root of 9 plus 25. 9 plus 25, which is 34, and that's in simplest form. So c equals square root of 34. Now we can go ahead and find the remaining 5 trig functions. We can start with the simple one, which is the cotangent. Not the simple one, but the one we can get directly from tangent. So cotangent of A, we said is a reciprocal of tangent, so it would be simply 3 over 5. And then if we look at sine of A, a look at the triangle. Sine is the opposite of the hypotenuse, which is 5 over root 34. So 5 over square root of 34. When we rationalize, we're going to get 5 root 34 over 34. Then let's do cosine of A, which is adjacent, which is 3 over hypotenuse, which is root 34. After we rationalize, it's going to be 3 root 34 over 34. So far we have tangent, cotangent, sine, and cosine. We need secant and cosecant. So with secant and cosecant, we just simply take the reciprocal of sine and cosine. In regards to cosecant of A is the reciprocal of sine, but we want to take reciprocal of 5 over root 34, which will be root 34 over 5. For the secant, we take a reciprocal of cosine, which is a reciprocal of 3 over root 34 becomes root 34 over 3. The reason why I didn't want to take the reciprocal of the final answer is because we're going to have to rationalize again if we do so. Now, we did talk about the reciprocal functions, which are the secant, cosecant, cotangent. Cosecant is a reciprocal of sine, and secant is a reciprocal of cosine, and cotangent is a reciprocal of tangent. But we're going to formally define those functions. So reciprocal functions. Given that f of x represents a function, if f of x does not equal 0, then 1 over f of x represents the reciprocal function of f of x. There's a condition, f of x must not be 0, because the 0 has no reciprocal. It is, of course, useful to know various trig identities. In some cases, those reciprocals are important to simplify some expression or to evaluate. So the reciprocal identities are cosecant, which is 1 over sine, and sine is 1 over cosecant. Secant is 1 over cosine, or cosine is 1 over secant. Cotangent is 1 over tangent, or tangent is 1 over cotangent. Example 4. If cosecant equals 2 and tangent equals 20, find each of the following. Find the sine. What do we know about the sine function? So let's do the sine. What do we know about sine function? Sine function is a reciprocal of cosecant. We know that sine of theta is 1 over cosecant of theta. And cosecant of theta is 2, so 1 over 2. What do we know about cotangent? Cotangent is a reciprocal of tangent. So cotangent theta equals 1 over tangent of theta. And what is tangent of theta? Tangent of theta is 20, so 1 over 20. Now we get to cosine. What is cosine? Cosine is a reciprocal of secant, but we don't have secant. But we have something else. We have tangent, we have sine, and we have cotangent. So with those, we can do something about it. So we know that tangent theta is sine theta over cosine theta. From this equation, we can solve for cosine of theta. Cosine of theta is sine of theta over tangent of theta. Do we know sine? Yes, sine is 1/2. Do we know tangent? Tangent is 20. So 1 over 2 times 1 over 20, which is the answer is 1 over 40. Now, in trigonometry, there are some triangles that are special triangles. So, trigonometric values for special angles. A triangle with special angles is special triangle. So, the first special triangle we're going to be looking at is the 30, 60, 90 triangle. So, if the angles of a triangle are 30, 60, 90, then there is something that will always be true. If the opposite to the angle 30, which is x, its measure is x, then the hypotenuse would be double of that. Always true. And then if you know these two, using Pythagorean theorem, you can determine the third side. So in a 30, 60, 90, if the opposite to 30 is x, the hypotenuse will be 2x, adjacent will be root 3 times x, or x times root 3. Now, if we want to find sine of 30 degrees, we know that the sine of 30 degrees is the opposite of a hypotenuse, which would be x over 2x. And this simplifies to 1/2. And this will always be true. Sine of 30 will be 1/2. No matter what the measure of the sides are, as long as it is 30, 60, 90, the hypotenuse will always be twice the opposite. And adjacent, as we said, is root 3 times x. So therefore, when we divide, we will always get the 1/2. Then if we find the cosine of 30 degrees, that's going to be the adjacent, which is x root 3 over 2x. Cosine, which is the adjacent over the hypotenuse. And then we simplify. This will simply be, simplify meaning we cross out the x and the x. So this will simply be root 3 over 2. And this will always be true. Cosine 30 is always root 3 over 2. And then the third one is tangent. So we do tangent of 30 degrees. Tangent is the opposite over the adjacent, which will be x over x root 3, which is 1 over root 3. And then if we rationalize, it's going to be root 3 over 3. 1/2, root 3 over 2, root 3 over 3. Now let's do the sine, cosine, and tangent of 60 degrees. So sine of 60 degrees is the opposite, sine is the opposite over hypotenuse, which would be x root 3 divided by 2x. After we simplify, it's going to be root 3 over 2. Root 3 over 2. Now let's do cosine of 60 degrees. Cosine, which would be the adjacent over the hypotenuse, which would be x over 2x, which is simply 1/2. And the last one is tangent of 60 degrees, which is the opposite over adjacent. So x root 3 over x, which is simply root 3. Over 2, 1/2, and root 3. Notice that we didn't talk about secant, cosecant, and cotangent, but they are simply the reciprocal of the sine, cosine, and tangent. Another special triangle is 45, 45, 90. So 45, 45, 90 degrees. It's another special triangle. So two sides will be congruent. Two sides will be congruent. This side and this side will be congruent. So if this side is x, this side will be x. Then if you use Pythagorean theorem, the hypotenuse will be root 2 times x. Now we're going to do the same thing. We're going to find this sine of 45 degrees. We're also going to do cosine of 45 degrees. And we're going to do tangent of 45 degrees. Notice here 45 equals 45. So we don't have to do this twice. We just have to do it once. Sine of 45 is the opposite of a hypotenuse, which is x over x times root 2, which is 1 over root 2. After you rationalize, it's root 2 over 2. Cosine of 45, again, it would be x over x times root 2, which is 1 over root 2, which is root 2 over 2 after you rationalize. Now, tangent of 45 is opposite of adjacent, which is x over x, which is 1, and that's the simplest one. So root 2 over 2, root 2 over 2, and 1. And this will always be true. Sine 45 will always be root 2 over 2. Cosine 45 will always be root 2 over 2. And tangent 45 will always be 1. So these are the two special triangles, 30, 60, 90, and then 45, 45, 90. Here's practice question. What is cosecant of 30 degrees? So if we go back to what we just did, we know that the cosecant is a reciprocal of sine. And sine, we found that sine of 30 degrees is 1/2. And the reciprocal of 1/2 is 2. So it means cosecant of 30 degrees is 2 over 1, which is simply 2. And of course, we got this from the table above. Secant 60, secant is a reciprocal of cosine. So let's go back and look for cosine of 60. So cosine of 60 is 1/2. So we're talking about the same thing. So cosine of 60 reciprocal, secant of 60 is reciprocal of cosine of 60, which is reciprocal of 1/2, which is 2 over 1, which is 2. Next, example 6. Question says calculate the height of the building to the nearest whole foot. So here's the building that you see over here. We need to find the height of the building, which is D. And what we know is the 76 degrees angle that's between, this is called angle of elevation. So this person, assuming he's looking to at the top of the building, and 200 feet is the 200 feet is the distance from the person standing and the standing person and the building. So this is a right triangle, and we know the angle is 76 degrees. We know one of the sides of the triangle is 200 feet. So the only thing we don't know is the opposite to 76. So what we can do, we know that tangent of 76 degrees is the opposite, which is D, divided by adjacent, which is 200. So D equals 200 times tangent 76 degrees, and this equals to 802 feet. This is rounded to the nearest foot. Now let's look at the inverse trigonometric functions. Inverse trigonometric functions. Going back to the basics of inverse, if a function f applied to an input x, so we have a function f taking some x value as an input, produces an output of y. So this function takes x as an input, produces y as an output. Then what does the inverse function do? So the inverse function, f to the power of -1, which means the inverse, this inverse function would take the y as an input, and it produces back the x as an output. So it takes y as an input, produces back x as the output. Inverse function pretty much what it does, it reverses the input and the output. Now, if f of x equals y, then f inverse of y equals x. We start with x, we end up with y. We start with y, we end up with x. That's what the inverse function. Does. Now, inverse trigonometric functions are used to find measure of an angle, and the symbol sine to the -1 is pronounced as sine inverse, not the reciprocal of sine. We need to be careful. We don't want to mistake the sine to the -1 with the reciprocal. It is the inverse, which is different. Now, example, if we have sine of theta equals 1/2. So the input here is theta. This is the input. And the output is 1/2. So if I take the inverse of the output, I should get back the input, which is theta. So sine inverse of the output equals the input, which is theta. And that's why we can use inverse trig functions to find the angles. Now in this case, if we go back to what we just did, sine theta equals 1/2. So sine theta equals 1/2. That's true when theta is 30 degrees. If we go back over here, sine 30 degrees is 1/2. Sine 30 degrees is 1/2. So sine inverse of 1/2 is 30 degrees. So the angle is simply 30 degrees. Okay, 30 degrees. Okay. Example 7 says find the measures of angles A and B rounded to the nearest degree. So let's find angle A. We know the measure of all the sides, so we can actually use any trig functions. I would go with tangent, but you can use, of course, sine or cosine or any other function, but I like to use tangent. So tangent of angle A is the opposite, which is 9, divided by the adjacent, which is 14.4. Now, to find angle A, we take the tangent inverse of 9 over 14.4. You plug this in your calculator, and you should be getting 32 degrees. Now, let's do angle B. We can also use tangent for angle B. Or probably we don't need to use any trig function for B. Why? If this is 32 and this is 90, so this would be 180 minus 90 minus 32. Right? Because the sum of the, in geometry, we learned that the sum of the measures of the angles of a triangle will be 180. So it means if we write b plus 90 plus 32, that's 180. So b will be 180 minus 122, which would be, in this case, 180 minus 122, which would be 58 degrees. 58 degrees. And of course, we could use a trig function to find this angle as well. Go to example 8. Example 8 says find the measure of the indicated angle rounded to the nearest degree. Let's start with example A. We don't have much choice here, but let's use cosine function. Cosine x is adjacent, which is 15, over hypotenuse, which is 17. And from here we say, okay, x is cosine inverse of 15 over 17. Cosine inverse 15 over 17 is approximately 28 degrees. Make sure your unit is set to degrees in your calculator. Shouldn't be in radians because we're looking for a measure of an angle to the nearest degree. All right, let's work on example B now. For B, we can use tangent. So tangent of x is the opposite, which is 27 over the adjacent over 18. So x equals tangent inverse of 27 over 18. You can simplify 27 over 18 if you wish, but we're just going to put it in the calculator and find the value, which is going to be approximately 56 degrees. Last example, which is example 9. It is a word problem. So the question says, a falcon at a height of 200 degrees. So I see the bird somewhere here. It's kind of not clear. A falcon at a height of 200 feet. So the height is 200 feet. Sees, let me highlight. So falcon at height of 200 feet sees two mice, A and B. So let's find these two mice, A and B. Let's use, okay, so A and B, as shown in the diagram. So question A says, to the nearest foot, what is the approximate distance z between the falcon and the mouse B? So the distance z, let's make sure we all see it, is this one. This is the distance z. Let me use a color that's more obvious. This is z. So that's what we're talking about, this distance z. So from the given information, we know that this triangle is a right triangle. And we are looking for z, and we know the adjacent to 72 degrees. There is an angle between the adjacent and the hypotenuse. This is 72 degrees. Adjacent is 200, and hypotenuse is z. So adjacent, hypotenuse, cosine function would work. So we say, okay, well, we know that cosine of 72 degrees equals adjacent, which is 200, divided by hypotenuse, which is z. Since we're looking for z, then we say z is 200 over cosine of 72 degrees. And when you divide 200 by cosine 72 degrees, you approximately get 647 feet. And that's the distance between the Falcon and Mouse B. Next question says, how far apart are the two mice? So how far apart are the two mice? We're talking about this distance over here. Okay, this distance, which is y. It's referred to in this example with y. If we determine the distance from mice B to the tree, to where the falcon is, I mean the horizontal distance, between B and this point over here, let's call this point W. So if we determine the distance between B and W, and we determine X, which is the distance from W to A, then let's call this D, then Y would be D minus X. Y would be D minus X. So we need to find D and X. To find D, we can use the tangent function. Tangent of 72 is D over 200. So let's write that down. Tangent 72 is D over 200. That means D is 200 times tangent of 72. Okay, now what is X? Look at the diagram. X is the distance from W to A, and there is here another triangle, this triangle, whose this angle over here is 62. X is the opposite, adjacent is 200, so we can use tangent again. So tangent of 62 equals X over 200. So tangent of 62 is X over 200. That means X equals 200 times tangent of 62 degrees. Now we said, let's go back to the figure. We said that Y equals D minus X. So let's write Y. Let's write Y equals, we said D minus X, which is 200 tangent 72 minus 200 tangent of 62. If I take 200 as a common factor, then it's going to be 200 times tangent 72 minus tangent 62. Of course, this step is optional. You can go ahead and just put everything in the calculator. So when you do the work, you're going to find 553 feet. This answer is rounded to the nearest feet. This is the end of my presentation. Thank you for watching.